let's try 465 divided by 0.08. Again, to make sense of this, we're going to have to revert back to understanding decimals as fractions. 465 is 465 ones, just a whole number. 0.08 really means 8 hundredths, right? Tenths, hundredths. So I'm dividing by 8, so I can show that times 1/8. Dividing by hundredths, dividing by 100, that means times 100. If I just do 465 divided by 100th, how many pennies go into 465? Well, 465 divided by 100th times 100. 465 times 100. Right? How many pennies go into $465? Well, 100 pennies per dollar, so that's 46,500 pennies, right? I'm dividing by, I'm making it bigger. Same thing here. Dividing by 100, I'm making it 100 times bigger. Now I could write this as 46500 multiply by 100 first, then divide by 8. And if I'm going to have to bring in extra zeros anyways, I might as well do that. But in general, I just do the 465 divided by 0.08. But since I don't know my multiples of 0.08, I know my multiples of 8. I want to convert this 0.08 into a whole number 8. So we can actually write this as a fraction a slightly different way. 465 divided by 0.08. And then we saw this times 100. Let me go ahead and multiply by 100. 100 hundredths here, right? This is really 8 hundredths. If we multiply that by 100, that's going to cancel. So 465 over just plain 8, right, times 100, that's shifting it 2 places over. That's canceling. I get the whole number 8 for my denominator. But if I'm going to change 8 hundredths into 8 wholes, I also need to change the numerator, right? I can't just multiply the whole number by 100th. That's changing its value. I have to multiply by 1, which in this case I want 100 hundredths. So I have 465 The quick way of showing that is, how did this become the whole number 8? Times 100 shifts the decimal over 2 places. So it's 465, 5 in the ones place. This shifted 2 places, so this shifts 2 places. So my decimal point is now over here with those zeros as placeholders. And that's a decimal point, not a 1. This may mean that it's going to go into 465 evenly, and I've got some extra zeros here. Or it may mean I'm going to have to add more zeros at the end. I don't know until I do the long division. So let's get into that long division again. 8 doesn't go into 4. 8 goes into 46 5 times. Remainder 6. Make my 0 look like a 0. Bring down the 5. 8 goes into 65 8 times. Bring down this first 0. That's helpful. 8 goes into 10 1 time. Bring down this next 0. 8 goes into 22 times. 8 times 2 is 16. 20 minus 16 is 4. I need another 0 here. So I just put it there, but my decimal point is unchanged. The decimal point is still there. Right? 8 goes into 45 times, and there's my answer. 465 divided by 8 is not the same as 465 divided by 0.08. 465 divided by 8, we got 58 and change. 465 divided by 8 hundredths, we get 100 times as much. This 58 is now in the hundreds place. We get 5,800. That 0.12 is now a 10 and a 2. And then the 5 is there. Right? And I can put my comma for the thousands versus hundreds place. So, long story short, when you're dividing by a decimal, you multiply by as many tens as is necessary to make this a whole number. If we're multiplying our denominator by a bunch of tens, we have to multiply our numerator, our dividend, by just as many tens. So that moves over just as many places. And that's now where our decimal is. Whether we need to add extra zeros or whether we stop short, that's it. So let's try one more example of this. How about instead of 465, we go back to 4.65. And instead of 0.08, let's try 0.9. Okay, so try that one on your own, and let's see if we get something similar. All right, so first step, I don't know my multiples of 0.9. I want to think of that as just a whole 9. So I multiply by 10, which means I multiply this by 10. So my decimal point, I've rewritten this problem that it's now the equivalent problem, 46.5 divided by 9. Right, that's equivalent to what started before because I multiplied by 10 tenths. Now I can say 9 goes into 4. It doesn't. 9 goes into 46. 5 times 9 times 5 is 45. 46 minus 45, remainder 1. Bring down the 5. 9 goes into 15 just one time. 9 times 1 is 9. Get a remainder. So 5, 6. You're not going to say 5.1 remainder 6, right? 5.1 and 6 ninths, that's not a thing. You don't have a mixed number with a decimal and a fraction. If we were going to do that, we would say 5.1, that means 1/10 and 6 ninths. Well, long story short, the whole number turned out to be 5, right? 46.5, 5, and then 5 tenths and 15 ninths. This is kind of a mess, right? We're not going to mess around with mixed numbers, with remainders and decimals. If we're doing decimals, we're locked in. We just put our zeros out here and keep going until we stop. So 9 goes into 60. 9 times 6 is 54. Remainder 6. Okay, bring down the 0. 9 goes into 60. 6 times 9 times 6 is 54. 60 minus 54 is still 6. Again, I have 60 minus 54. 60 minus 54. If I bring down this 0, it's going to be 60. 9 goes into 60. Same thing over and over again. Now, the fact that I happen to get 6 twice in a row is not enough to tell me that that 6 is going to repeat indefinitely. I don't know why I had that extra line there. Right? The reason why I know this 6 is going to go on forever is because all I'm going to ever bring down is another 0. It will only ever be 60. That's going to be unchanged. And that's how I know my answer is 5. Let's rewrite that. 5 point, the 1 is just there, and then the 6 repeats forever. And when we have a decimal point that repeats forever, we put a line over it to show that that goes on. It's not 5.16 or 5.166 or even 5.167, right? We're not rounding unless our directions tell us to round. But we also don't want to spend the rest of our lives and our children's lives and our grandchildren's lives writing 6 forever. We just recognize, okay, it's going on forever. I show the 1 doesn't repeat, the 6 does repeat, and we're done. Okay? Let's do one more example with the repeating decimal. Which one did I want to do here? Let's say 70 divided by 11. Okay, so I set this up. Now, that 0 is important because it's saying the decimal is not after the 7, it's after the 0, right? This is 10 times bigger than 7/11ths. If I already know what 7/11ths is, I just slide the decimal and I'm done. I don't know what 7/11ths is. Let's actually do the division. So 11 doesn't go into 7. 11 goes into 76 times. 70 minus 66 is 4. 11 goes into 40. Not 6 times. It's not going to be 6 forever. 11 goes into 43 times. Because 11 times 3 is 33. Now I get a 7 again. Now, sometimes I'll put a whole bunch of zeros here. That's what I did this time, and I didn't even use all of them. This time I put 6 zeros here. I only needed 3. Sometimes I don't feel like that. I just put them one at a time. It's complete personal preference. You know there are as many zeros here as you want to use. You just have to decide how many of them are necessary. So 11 goes into 70 6 times. Put in that next 0. Notice I'm not getting 70, 70, 70, 70. But there is a pattern here. 70, 40, 70, 40. How many times does 11 go into 40? 3 times. Come on. And 11 times 3 is 33. 40 minus 33 is 7. There's my 70. Right? 70, 40, 70, 40, 70, 40, 70, 40. So what's happening with our quotient? 6, 3, 6, 3, 6, 3, 6, 3, 6, 3. That 63 is repeating over and over again. But this is not a thing. The whole number has to be stated as a whole number. Whether it's a 1-digit whole number or a 5-digit whole number, whatever it is, it's a whole number. And then once we get to the decimal, I have to see what comes after the decimal point. 3, and then a 6, and then a 3, and then a 6. So that is my answer. That's how we deal with repeating decimals. Now, I knew ahead of time that this would repeat because of my divisor being 11. I knew ahead of time that this would repeat because my divisor was 9. I knew ahead of time that this would not repeat because my divisor was 8. Now, what's special about 8 versus 9 or 11? Well, we could say 11 is a prime number, but 9 isn't a prime number. 9 is 3 times 3. We could say 8 goes into 10, but it doesn't go into 10. Right? If I divide by 2, I know I'm going to end up with a half. Right? And a half is 0.5. So I know eventually that's going to end. Well, 8 ends for the same reason. If I divide by 10, that's just moving the decimal. Whatever it is that's being divided by 10 is really being divided by 2 and 5. So if I divide by 2, it's kind of like I'm dividing by 10. I just have to multiply top and bottom by 5. Right? Now, I use that all the time to divide by 5. if I take, say, 860 divided by 5, I can't do that in my head. Right? I can do the long division. Maybe I can do that long division in my head, but I have to really concentrate. But 5 times 2 is 10. I can double 860 in my head, right? Double 8, you get 16. Double 6, you get 12. So that's 172, right? 160, 172. And then with an extra 0. Divided by 10, that's just 172. Or I could think of it the other way. 860 divided by 10 is 86. Cancel that 10 first. 860 times 2 over 10. Cancel the 10 first. Double 86. Double 80, you get 160 plus 12. 160 plus 12, 172. Right? I'm not writing this on my paper. That's how I'm dividing by 5 in my head. Anytime we're dividing by a 5 or a 2, we can just multiply by the missing factor, and that means we're dividing by 10. What does it have to do with dividing by 8? Well, if I take 465 divided by 8, what are the factors of 8? 2 and 2 and 2. Well, how do I get 10 from 2? I do 2 times 5 to get 10. 2 times 5 to get 10. 2 times 5 to get 10. 10 times 10 times 10. 10 times 10 times 10. 5 times 5 is 25. 25 times 5 is 125. So I have 465 times 125. This might take a minute. 5 times 5 is 25. 5 times 6 is 30 plus 2. 5 times 4 is 20 plus 3. Move over. 2 times 5 is 10. 2 times 6 is 12 plus 1 is 13. 2 times 4 is 8. 8 plus 1 is 9. Move over 2 places. 1 times 5. 1 times 6. 1 times 4. Add that all up. I get a 5 and a 2. 5, 6, 7, 8, 9, 10, 11. 9 plus 1 is 10, 16, 17, 18. 58125 thousandths. So this is the thousandths place, which means this is the hundredths place, which means this is the tenths place. So there's my answer. 58.125. 465 divided by 8 is the same as 465 times 125, then divided by 1,000. 58.125. 58.125. Now, let's pause. If this was our problem, I think this long division is probably going to be easier than trying to factor, bring in all these 5s. I'm not suggesting that this is the way you would get your answer. What I want you to see is that for any fraction, if my denominator is made up of a bunch of 2's multiplied together and a bunch of 5's multiplied together, then just pick another letter here, P for power, I guess. We can multiply by whatever 2's and 5's are necessary to be dividing by 10. which means I have a finite decimal. I have 58,125 in the thousandths place in this case. It's either going to be in the tenths or the thousandths or the 10 billionths, but eventually I get a whole number and I'm just sliding the decimal place over a bunch of times. But if I have anything else in my denominator, say an 11 or a 3 or a 7, and it doesn't cancel, then I'm not going to get just a power of 10 as my denominator. I'm going to get some combination of those other factors. So let's say I take 465 divided by 12. That's got 2 and 2 and 3. Well, 465 is a multiple of 3. 465 divided by 3. Oh, we already did this, 155, right? So 465 is 3 times 155. The 3's cancel. So now I do only have 2's left there. So 465 divided by 12 will be a finite decimal. And if I just do that quick, it's not going to go in evenly into the whole number. Let's slide this over a bit. Okay. So 12 goes into 46 3 times only. 46 minus 36 is 10, bring down the 5. 12 times 10 is 120. So 12 times 8 is what I want to use. 12 times 8 is 96. 96 plus 4 is 100, plus another 5 is 105. 4 and 5 is 9. I get a remainder of 9. But I can bring down a 0. 12 to 90, 96 is too much, so I'm going to put a 7 there. My decimal point was there, so it stays there. 12 times 7 is 84. Another 0. 12 goes into 65 times. 12 times 5 is 60 on the nose. So I had to bring in a few zeros, but eventually it ended, right? Notice I'm dividing by 4, so I get 3/4 as a remainder. Right? 155 divided by 4 is 38, remainder 3, 38 and 3/4. I don't suggest you do this factoring stage. Notice I didn't do 155 divided by 4 for my long division. What I'm showing in this factoring stage is if our divisor is not a multiple of 2's and 5's, but one of those other factors cancels, we do still get a finite decimal. But if I had 466 divided by 12, it starts off very similar. 12 goes into 4. No, 12 goes into 46 3 times. Bring down a 6 now instead of a 5. So 12 times 8 is 96. Now remainder 10 instead of remainder 9. Put my decimal points in, bring down a 0. Now I'm not doing 12 into 90, I'm doing 12 into 100, so that's 86 again. Bring down another 0. 12 goes into 40 3 times. Bring down another 0. 12 into 40. 12 into 40. All I'm going to do is bring down more zeros. 12 into 40 is 3. 40 minus 36, remainder 4. It's just going to be all these 3's. So we get 38.83. The 3 is what repeats, so put a line over the 3. It looks kind of symmetrical. That's just coincidence. This 3 is not the same as this 3. This is 3/100ths, and also 3 thousandths and 3 10 thousandths and so on. Right? So the point is this: when your divisor is not an obvious multiple of 2 or 5, or 2 and 5 exclusively, then you're probably going to get a repeating decimal. Sometimes you don't get a repeating decimal just because something canceled that you didn't even expect. So that's how we can recognize when it will repeat versus when it doesn't repeat. And I think that's it for our decimal division.